Greetings to my good folks at the RMC. This is Kami, video casting from downtown Kingston. I hope you've had a good day under the circumstances and that better days will come. Today, I want to turn the page to another chapter in our journey, and that is decontamination. As an example of that idea, you're looking at a detailed decontamination of a large armored personnel carrier. Another example is this decontamination of an F-16 fighter jet of the United States Air Force. Now, I have asked my friends at the CBRN unit in Trenton to provide me with the decontamination procedure of a Royal Canadian Air Force plane, and they have said yes, and I'm looking forward to receiving that for some time in future. But let's explore the idea, the concept of decontamination. Why do we decontaminate? Effective and proper decontamination prevents the exposure to and the spread of chemical warfare agents. Proper and effective decontamination also allows for critical personnel, units, and their equipment to be reactivated and redeployed in critical operations. So, what are the determining factors and variables in the process of decontamination? First and foremost is the toxicity of the agent. And in that, we determine the LD50 of liquid agents or LCT50 of the vaporous agents. You are familiar with those concepts. The more lethal those numbers, we have to be more proactive in decontamination and prioritizing it. Next one is persistency. As an example, a non-persistent chemical warfare agents with high vapor pressure will evaporate in very short period of time. Therefore, do we need to expand our limited resources decontaminating something that will be gone in a matter of hour or less? Next one is if we are in a situation that we have received a large dose of chemical warfare agents, in other words, a high concentrations of it. Again, that will prompt decontamination to a higher level. In that context, you as senior officers must evaluate your supplies, your trained personnel, your IPEs, individual protective equipment, in order to assess whether and to what extent you can decontaminate. Another one is if there is a large-scale contamination transfer, a possibility that brings with it high risks. So therefore, in this context, decontamination must really be accelerated. And as I said earlier, if there is a unit that its reactivation and redeployment is critical to our operation, their decontamination will take priority. So let's look at decontamination options that we have available to us. And it's a science to its own. First of all, the best decontamination is destruction, complete destruction of the agent. By that, we have chemical reactions and physical processes that alter the nature of chemical warfare agents. In other words, at the end of those chemical reactions and physical processes, we no longer have the chemical agent. Therefore, the toxicity and the lethality is gone. Next one is the physical removal of an agent. So we're talking about the removal in a physical sense. In other words, if there are means available that by increasing temperature we can accelerate the evaporation, that's a good option. Maybe limited, but that's a good option. Or the use of super absorbing materials like clay to permanently soak up the chemical warfare agents for later destruction and disposal. Last but not least is physical screening of the chemical warfare agents. And by that meaning that we have contaminated equipment and other materials buried in earth, sealed in concrete, or structures that are contaminated being painted or varnished with a thick layer. So those chemical warfare agents are permanently sealed and rendered ineffective. I'm going to spend a little bit of time on destruction of agents. In other words, chemical and physical means. So let's look at that together. Now, as I said, when you alter a chemical molecule or a chemical formula, it is altered and is no longer have the properties of the initial chemical compound. I'm going to jump to the bottom of the list and look at thermal. And I'm going to give you a very simple example. You pull up to a gas station, you fill up your car with gas, and off you go on the highway. Your car has an internal combustion engine that operates at very high temperature. What comes out of your tailpipe is carbon dioxide and water. No gasoline is coming out of your tailpipe. That physical thermal process has altered the gasoline into production of carbon dioxide and water. So it's no longer gasoline. That was we call an example of thermal transformation. Now, in other chemical processes or chemical reactions, we have oxidation, chlorination, and hydrolysis. But here's a bit of good news. Oxidation and chlorination happen in conjunction with each other. And you're looking at something that everybody's got in their home. Bleach, yes. Used extensively for cleaning the bathrooms and public places. Bleach has oxidizing and chlorinating capabilities. And as an example, the supertropical bleach is calcium hypochlorite, and in the formula you can see that you have a chlorine for chlorinating and you have an oxygen for oxidizing. Chlorine and oxygen are very highly reactive components of this formula. And in reacting with chemical warfare agents, they destroy that agent, our ultimate goal, and the products are no longer chemical warfare agents. The same calcium hypochlorite, in conjunction or in addition to a foaming agent, is referred to as German emulsion. Now, what is the advantage of that? So you get the same oxidizing and chlorinating property of the bleach, but the foam penetrates the subsurfaces of a lot of materials and structures and destroys the chemical warfare agents. And the chemical warfare agents that are destroyed by bleaching agents are nerve agents and mustard. Great. Very, very effective. Now, in here, you're looking at application of German emulsion, or C8, to a armored personnel carrier. And you will appreciate at why the foaming agent gets into all those subsurfaces, nooks and crannies to neutralize and destroy the chemical warfare agents that are lurking in those places. Next, we look at the hydrolysis. What is hydrolysis? A very simple concept. Hydrolysis is dissolving in water or reacting with water. So, imagine Kami has been busy in his spare time and has invented this horrifying chemical warfare agent. It's called AB. This AB, in reaction with water, HOH or H2O, produces two products, AH and BOH. So AB dissolves in water or reacts with water, produces AH and BOH. That is a balanced chemical reactions, and I'm sure you noticed that. But look at the products AH and BOH. AB, Kami's horrifying chemical warfare agent, does not appear. AB is neutralized and destroyed by hydrolysis. So, the hydrolysis, or reacting with water or dissolving with water, a great way to destroy Sarin, GB, and VX. The next level up is the decontamination solution 2. It has a variety of chemistry going on, including hydrolysis. So many things going on in chemistry. One of them is hydrolysis. In DS2, you can neutralize variety of nerve agents and mustard in less than 5 minutes in the operational temperature of 26 to 252, which is great. One word of caution, folks. You have appreciated hydrolysis as reaction and dissolving in water. Mustard HD has almost no solubility in water. Almost none. And it has haunted the fishermen in the North Sea that pull up mustard cylinders or blobs of mustard that date back to 60 or 70 or even more years ago. As they're pulling up the nets, these blobs explode when they reach the deck of the fishing boat and victimize people, like the picture I've shown you with the telltale signs of a blister agent. So again, mustard is the only chemical warfare agent that is not soluble with water, and it preserves itself lurking in the shadows waiting for a victim. Last but not least is a Canadian product. Yes, a product developed for the CAF, and that's Reactive Skin Decontamination Lotion, or RSDL. This is used to decontaminate large surface areas of skin that are subject to chemical warfare agent exposure. And in 10 minutes, it produces a very satisfactory result. Folks, this will mark the last video cast for this course. I miss the atmosphere of the class. I miss all of you. I miss your energy. I wish it could have been different, but we shall never surrender. Thank you for being you. Thank you for your support. My thoughts are with you.